Hello everyone. I hope you are fine and good. So this is your Professor Brahim Gizeni, and today I am going to present this chapter number 5. It's about the theory of consumer choice. I remind you that this presentation is based on the textbook Principles of Macroeconomics by Gregory Mankiw and the slides of Professor Ron Cronovich. Okay, let's talk then about the theory of consumer choice. What is the objective of this chapter? In this chapter, we will see what the economic theory says about consumers' decision making, how consumers make decisions. Consumers' decision is, of course, about what to buy. You can imagine the situation: you are a consumer, you enter a store or a market, and there are plenty of goods, and you want to know, and you might ask why these consumers, some consumers, buy specific quantities for specific goods, and others buy different quantities for other types of goods. So this is the objective of this chapter. Is we will learn what are the factors that intervene in the mind of the consumers that makes him choose a certain combination of goods and services. Okay? So let's see. The objective of this chapter will answer these following questions. How does the budget constraint represent the choices of consumer can afford? How do indifference curves represent the consumer's preferences? And what determines how a consumer divides her resources between two goods? And how does the theory of consumer choice explain decisions such as how much a consumer saves or how much labor she supplies? Okay, so we'll first then learn some new concepts and define them. This first concept is the budget constraint. And then the second concept in the theory of consumer choices is about, it's called the indifference curves. Okay? So let's start with this example. As I said, suppose in a store you are, as a consumer, confronted to thousands of goods that you might buy. Thousands of goods that you might buy. And of course, the first thing anyone might, of course, annoy him is that there is a limited resources. This reminds us the concept of scarcity problem. We have seen that economics is based on the concept of scarcity. A consumer who enters a store, most, if not all, consumers must have limited resources. Means they have a specific budget. So you cannot buy everything you want. This reminds us the principle number 1 we have seen in chapter number 1 is that people face trade-offs. So here you can imagine and you can predict that this consumer is going to make trade-off. This trade-off will make him choose certain types of goods and services and give up other goods and services. So this is the trade he's confronting. So Given the prices and your resources, you make a trade-off and buy a bundle of goods that best suits your preferences according to the needs and desires. So here this trade-off is made because we have limited resource. This is the first important word in this sentence, and your choices of the goods depends on your budget resources, and then of course you want to use your resources to buy the goods that best suits your preferences. So the choice is also based on a second factor that is preferences. The first factor is resources, and the second factor is preferences. And these two factors explain the quantity or the combinations of goods that the consumer would buy. So we recall the principle of, we have seen in chapter 1, people face trade-off, means buying more of one good leaves less income to buy other goods. So there is a trade-off between goods. This can be extended to the trade-off between working hours and leisure time, between labor and leisure. This also can be extended to another situation, this trade-off between saving and consumption. Reducing saving now allows more consumption now, today, but reduces future consumptions. So we always face trade-off, and consumers face trade-off. Why there is trade-off? Because of their limited financial resources, because of their limited budget. So the budget, the resources, financial resources, is a key factor in consumers' decision making about what to buy. So the budget and the financial resources is an important element in this theory of consumers' choice. So in this chapter we will learn the theory that describes how consumers make decisions about what to buy. This theory is called the consumer theory of choice. So let's first start with the first important element in this theory, which is the budget constraint. The budget constraint, we mean by the budget constraint is the financial limitation any consumer faces. So let's see this example. We have Harley, who is a consumer, who has an income of $1,000, and he is looking to divide this income between two goods. Of course, in the real world, we have thousands of goods, but here, for matter of modeling, and you know that when we work on models, we should simplify the reality. So we will assume that in this simplified world, there is only two goods, pizza and Pepsi drink. The pizza price is $10 and the Pepsi drink is $2. And Harley have an income of $1,000. And he is looking to spend his income on pizzas and Pepsi drinks. So here we define a consumption bundle. A consumption bundle is the particular combination of the goods. So it's a combination of goods. For example, 40 pizzas and 300 liters of Pepsi drink. This is one of combination among many. So when we say consumption bundle, we mean a combination of goods and services. So let's see this example. So here we have Harley, who is going to divide his income of $10,000 buying pizzas and drinks, Pepsi drinks. The pizza, as I said, is price is $10, and Pepsi is $2. This table represents many possibilities or many consumption bundles for Harley. Of course, total spending of Harley, total spending should not exceed $1,000. Why? Because his income is $1,000. He has a limited income, only $1,000, so his spending on goods and services should not or cannot be over $1,000. Dividing this income between pizzas and Pepsi can be represented by many possibilities. For example, he can buy 100 pizzas, and this spending on pizza will be $1,000. So he's spending $1,000. So there is no money left to buy Pepsi, sorry. So the number of liters of Pepsi would be 0, and the spending on Pepsi would be 0. So 100 pizzas and plus 0 Pepsi is one possible combinations of this consumer. This consumer can also choose another combinations of these two goods. For example, 50 pizzas, 250 liters of Pepsi. The total amount will be $1,000. He can afford another combination, 20 pizzas, 400 liters of Pepsi, which makes spending on pizza $200, spending on Pepsi $800, and total spending is $1,000. So you see here, total spending is always $1,000, but there are many possible combinations between pizzas and Pepsi. So Harley has, let's say, infinite possibilities, infinite bundles of consumption bundles he can choose. Okay, let's if we try to draw the curve of these combinations, and let's put on the y-axis the quantity of Pepsi, and in the x-axis the quantity of pizza, and we put all these possibility on a graph. What we get this curve, this line, straight line curve, where each point of this curve represents consumption bundles a consumption bundle that Harley can afford given his income of $1,000. He cannot afford a combination here, this combination X. He cannot afford. Why? Because this X combination is beyond his budget limit. To buy this quantity of this combination of goods represented by this point X, he should have an income higher than $1,000. So he cannot afford this X. It's impossible. If a combination here, let's say, I call it Y, okay. Inside the curve, any point would represent a combination that Harley can afford. But if he buys this combination of goods and services, he will still have money left. So he's not spending the whole amount of income he has. However, this blue line represents all combinations that Harley can, all combinations of Pepsi and pizza that Harley can afford spending the totality of his income. We call this curve the consumer's budget constraint. This curve and this graph on this graph represents the consumer budget constraint. It represents all the consumption bundles that consumer can afford given his income, and it is made from this table. Okay, we can define then the budget constraint. The budget constraint is the limit on the consumption bundles that the consumer can afford. Define it as well as a consumption possibilities frontier. It is a consumption possibilities frontier for the consumer. It shows all combinations, bundles of the two goods that the consumer can afford to buy. Why? So this consumption possibility frontier reminds us the production possibility frontier we have seen before. You remember the production possibility frontier represents the all possible production combination that a firm can produce given its resources of inputs. The production possibility frontier is used for firms and producers. When it comes to consumers, we talk about the budget constraint, which is a consumption possibilities frontier. Given the consumer's income, it represents the limit of consumptions that of two goods that the consumer can afford to buy. I hope it is clear by now, the meaning of the budget constraint. And it is represented graphically as this straight line like this one. Let's see now the meaning of the slope of this budget constraint. What is the meaning of this slope of the budget constraint? Let's now work on another example. We have we have mangoes and fish. Okay, and we have here a budget constraint. In the y-axis we have mangoes, quantities of mangoes, and in the x-axis we have quantities of fish. So here our consumer has, and we have here our consumer is spending his income on mangoes and fish, and his budget constraint is represented by this line, this straight line, where there are two possibilities of two combinations. The first combination we call C, and the second combination we call D. Imagine the first situation is C. Okay, let's imagine we start at C. And our consumer wants to move from C to D. At C, his bundle is represented by 800 mangoes and 100 fish. However, it seems that our consumer wants to move to D, so he gets 150 fishes. So he wants 50 additional fish. Of course, and unfortunately for him, his budget is very limited, and he cannot add more fishes without giving up some mangoes. If he wants more fishes, he should give up some kilos of mangoes. Why? Because he has a limited budget. So in order to get this 50 additional kilos of fishes, he has to give up 200 kilos of mangoes. So his total spending does not change. So to move to the consumption possibility as C to D, he has to give up 200 kilos of mangoes in order to get 50 kilos of fish. So this make us we can then compute the slope of this curve, which is minus 200 over 50, and we get minus 4. So obviously the curve has a negative slope. So Harley then must give up 4 kilos of mangoes to get 1 kilo of fish. So the slope of the constraint actually represents how much a consumer should give up from of the, let's say, the good, the mangoes here, to get 1 additional unit of fish. So the slope is minus 4. This means that this consumer Harley, to get 1 more unit of fish, he should give up 4 units of mangoes. Why he should give up 4 units of mangoes? Because he has a limited budget called budget constraint. He has limited resources. So consumer decision making is significantly related to his budget. If he or she changes combinations of his goods, of the goods he has, and he wants to change the combination, he must make trade-off. And this trade-off should be made by giving up certain quantities of a good number 1 to get more units of the good number 2. So consumers are always facing a trade-off. This trade-off is should be done because they have limited budgets, called budget constraint. Let's make this simple mathematics to compute the slope. Suppose PM the price of mangoes, which is $1. PF the price of fish, which is $4. Suppose MI quantities of mangoes for I being C or D. Fi the quantities of, sorry, not mangoes, but for quantities of fish for I is C and D. We know that totals on the any combination on the budget constraint like C and D, the total spending should be equal. So total spending at C is equal to the total spending at D. Let's compute total spending at C. Total spending at C is price of mangoes times quantities of mangoes at C plus the price of fish times the quantity of fish at C should be equal to the price of mangoes times the quantity of mangoes at D plus the price of fish times the quantity of fish at D. Let's say do some mathematics. So this gives us, from this equation, we get the slope of the budget constraint, which is MD minus MC, which is here delta M, over FD minus FC, which is delta F. So this is the slope of the budget constraint. And it is found to be minus price of fish over price of mangoes. So the slope of the budget constraint, actually it is a division of the prices of the goods, the two goods we have in this model. So the slope, I repeat, is delta M over delta F, the change in quantities of mangoes over the change in the quantity of fish is equal minus the price of fish over the price of mangoes. Please note that delta M over delta F is equal price F over price M. Okay. So here to distinguish which variable should be put on as a numerator and which variable should be put as denominator. If we work on quantities, here delta change in mangoes over change in fishes, and if we use the prices, it is minus the price of fish over price of mangoes. So the slope of the budget constraint equals the rate at which the consumer hardly can trade mangoes for fish, the opportunity cost of fish in terms of mangoes. So the opportunity cost, you remember the opportunity cost is what you give up to get something. In order to get fish, we should give up mangoes. So the cost, the opportunity cost of the budget, the slope of the budget constraint represents the opportunity cost of fish in terms of mangoes. So to get one more unit of fish, you have to give up 4 units of mangoes. It means the cost of one fish in terms of mango is 4 mangoes. And the slope is actually the relative price of fish. So it is the price of fish over the price of mangoes. 4 divided by 1 gives us 4 mangoes per fish. So the relative price of fish is 4 mangoes. One fish is priced as 4 mangoes. The price of fish in terms of mangoes is 4. Give me 4 mangoes, I give you 1 fish. If suppose we are in an economy where exchange and transactions are between mangoes and fish, we trade fish for mangoes. So the consumer, to get 1 more fish, he should bring with him 4 mangoes. Here we come to the second piece in our picture, which is preferences, consumer preferences. When we talk about preferences, we talk about the question what the consumer wants. What this means, what makes the consumer very satisfied. So when we talk about preferences, we mean satisfaction or happiness or well-being. So by choosing to buy, the consumer is expected to buy something that makes him happier. For example, if I am asked to choose between 2 cars, one Peugeot and another one Ferrari, what makes me happier for me is a Ferrari. I prefer a Ferrari than a Peugeot car. For example, another example, if I have to choose between 2 houses, one with a pool and another one without a pool, I want and I prefer having a house with a pool, because a house with a pool makes me happier. Another third example, if for example I'm asked to choose the quantity of mangoes that I prefer a large quantity rather than a small quantity of mangoes, because large quantity of mangoes or fish makes me happier than a small quantity. So when we talk about preferences, we mean satisfaction of the consumer, the well-being of a consumer. So this is the second, besides the budget limitations, the second factor that affects consumer decision making is about what he wants, what he prefers. So his preferences. And when we talk about preferences, we mean satisfactions. So let's see this part. The indifference, the happiness or preferences of a consumer is all like the budget constraint is represented on this plan of the two axes, quantity, where we have here quantity of mangoes, and the x-axis we have quantity of fish, we can represent the preferences of the consumer by also a curve. We call here I1 to mean indifference curve. The indifference curve represents the curve of satisfaction of the consumer. So this curve, it shows the consumption bundles that give the consumer the same level of satisfaction. So this curve is composed of infinite number of bundles of mangoes and fish that gives the consumer the same level of satisfaction. For example, here we have 2 points A and B. A and B all other bundles on this curve I1, indifference curve, we call indifference curve, make our consumer hardly equally happy. So he is indifferent between both A and B, because the bundle A and the bundle B give the consumer the same level of satisfaction. There are 4 properties of the indifference curves. The first property is that indifference curves are downward sloping. So this means that the slope of the curve is negative. Slope of the curve is negative. If the quantity of fish is reduced, the quantity of mangoes must be increased to keep Harley equally happy. So this negative slope of the curve means if I want more of one good, let's say mangoes, I should give up certain amount of fishes. The second property of the curve is that we can present many curves in this plan. Higher indifference curves are preferred to lower ones. Why? Because higher indifference curves are expected to give represents higher level of satisfaction. I1 gives a higher level of satisfaction than I1, and I1 gives a higher level of satisfaction than I0. So Harley prefers every bundle on I1, I2 like C to every bundle on I1 like A. So C is preferred to A because C is a point in a higher indifference curve than A. The third property, indifference curves cannot cross. They are parallel to each other. Why they cannot cross? Suppose, for example, we have this situation where two indifference curves, i.e. I1 and I4, crosses at point A. So Harley should prefer B to C, since B has more of both goods, and B is in a higher indifference curve than C. Yet, Harley is indifferent between B and C. Yet, Harley is indifferent between B and C. Why? Because he likes C as much as A. C and A are in the same indifference curve I4. And he likes A as much as B because A and B are in the same indifference curve. So this does not make sense at all. How come B can be both better than C and as good as a C, which is a nonsense. So this is why the indifference curves should not cross each other and they should be parallel to each other. The fourth property, indifference curves are bowed inward. Bowed inward means having this form. So this means that the slope of the curve is negative, but it is increasing as we go from the left side of the curve to the right side of the curve. Harley is willing to give up more mangoes for a fish if he has few fish, like in A. If he is in A, he has to get one more fish. He should give up 6 units of mangoes. However, if he reaches the bundle B, he has now more fishes than he had before when he was in A, so he is now less incited to get more fishes because he has already a large quantity of fish. So he would trade one more fish for less mangoes when he is in B. So now in B, to get one more fish, he just accepts just to give up only 2 mangoes instead of 6 like it was in the point A. So this is the property, the fourth property, that indifference curves are bowed inward. We talked about the slope of the indifference curve. The slope of the indifference curve is called the marginal rate of substitutions, or MRS. The marginal rate of substitution, MRS, is the rate at which a consumer is willing to trade one good for another. If the consumer is at A, he is willing to give up 6 mangoes to get 1 fish. So at A, his MRS is 6. However, if he is in B, he is willing to give up 2 mangoes to get 1 more fish. So Harley's MRS is the amount of mangoes he would substitute for another fish. The MRS is, of course, the slope of the indifference curve. And this slope is let's say, if it is mathematically it is negative, and it is expected to increase as the quantity of fish increases. MRS falls as you move down along an indifference curve. So here he says false, not increases, because the author works with a positive MRS. So he is removing the minus of the MRS and he takes it as a positive number. So if you look to this MRS as a positive number, of course, along the curve, as we move along down along the indifference curve, the MRS would fall. But mathematically, if we take it as the math shows, and we know that the slope MRS is the slope of the indifference curve is negative, so we should see the MRS as a negative number. So as we move down along the curve, this negative number of the MRS is expected to increase. But in these slides, we will work with a positive MRS. A positive MRS means we are removing the minus, and we work with let's say its absolute value. Here, with the slides, we talk about extreme cases and forms of indifference curves. Some indifference curves for some combination of products can be having this straight line indifference curves, and when we have some straight line indifference curves, we say that the goods in this plan are perfect substitutes. Perfect substitutes to goods with straight line indifference curves and of course constant MRS. For example, nickels and dimes. Nickels and dimes are two American coins. Nickels is 5-cent coin and dimes is 10-cent coin. So consumer is always willing to trade 2 nickels for 1 dime. So always a consumer is willing because 1 dime is equal to 2 nickels. So the substitution between these two goods is always constant. So the MRS of the indifference curve of these two goods is negative, which makes these two goods is constant. So which makes these two goods perfect substitutes, and then their indifference curves are straight line indifference curves. Another extreme case with perfect complements. Here the two goods are perfect complements, means the two goods with right angle indifference curve, like we have here. Right angle indifference curves, 90 degrees angles. The example, left shoes and right shoes. If we here, like here, we have 7 left shoes and 5 right shoes. This combination or this bundle is just as good as 5 left shoes and 5 right shoes. So having more left shoes doesn't increase the satisfaction of the consumer. Having 7 left shoes with 5 right shoes has as much as satisfaction as having 5 left shoes and 5 right shoes. For this type, why why this is happening? Because these two goods are perfect complements. Each one is a complement to the other good. So less extreme cases: close substitute and close complements. Indifference curves for close substitute are not very bout. Having the indifference curve would have this green curve form. Indifference curves for close complements are very bout. Are very bout means having the form like this red indifference curve. Okay, now we have seen so far the two pieces in the picture that represent the picture representing consumer choices. The first to answer this question, how consumers make choices, we should put together these two pieces. The first piece is the budget limitation, we call it budget constraint, and the consumer's budget constraint. It's about how much she can afford to spend, the budget limitation. And the second piece is the consumer preferences, which is about what she wants to spend it on. It means the budget. So both factors or both pieces are, when they are put together, they can explain the consumer decision making. When the budget constraint and preferences are put together, we can understand or determine the consumer's decision about what to buy. So let's put these two pieces together on the same picture. So when we talk about consumer choices, here we talk about optimization. When we talk about optimization, especially in mathematics, we mean maximization or minimization. And here, when we consider the consumer choice, the consumer is expected then to maximize what? Maximize, of course, his preferences, his satisfaction. So he's expected to choose to buy the bundle, the combination of goods that gives him the highest possible satisfaction. A Ferrari compared to Peugeot gives me the highest satisfaction. However, I can't maybe buy a Ferrari because I have a budget limitation, so I can't afford it. So my optimization point, or my a bundle of goods that maximizes my satisfaction is different. Different. So let's see how consumer then put this his preferences and budget constraint together to find the bundle of goods that in the same time gives him the highest satisfaction possible, taking into account his budget limitations. Here we put together on the same graph, on the same plan of mangoes and fish, put together in different curves, that represent satisfaction, and the curve of the budget constraint. Let's look to the bundle B. The bundle B in the curve I1 gives more satisfaction to the consumer than the bundles C and D. However, the bundle B is on the right side of the budget curve or the budget constraint. This means that though B gives high satisfaction to the consumer, this bundle B cannot be purchased by the consumer because his budget is limited, and his budget cannot buy the bundle B because the bundle B is beyond the budget constraint. Okay, so B is not a solution for the consumer. Let's see the combination C, the combination of goods C. The combination of goods C, our consumer can afford the combination of goods C and D. Why? Because their indifference curve is on the left side of the budget constraint. So he cannot afford them. He can buy them. He has the necessary budget to buy these two possible combinations of goods. However, do C and D give the highest, C or D, sorry, give the highest satisfaction to the consumer? No, the answer is no. Why? Because there is another possibility, another combinations of goods that the consumer can afford. We call this combination A, that the consumers has the budget to buy, and this combination of good A give a higher satisfaction than the bundles in I2 and I2, sorry. Why? Because the combination, this point A, is on the budget line, so it is affordable, and it is also on this indifference curve I3 that is higher than the curve I2. So the solution appears to be the point or the bundle of goods where the optimization, or where the indifference curve touches the budget line. At this point A, the consumer gets the highest satisfaction possible, and this bundle is affordable because it is on the budget constraint line. So the A is the point of optimization. Here we represent A, composed of 600 units of mangoes and 150 units of fish. We call this point A is the optimum. The optimum. Why it is the optimum? It is the point on the budget constraint that touches the highest possible indifference curve. The optimum is the bundle the consumer hardly most prefers out of all the bundles he can afford. Out of all the bundles he can afford. He cannot afford B, budget limitation. He can afford C and D, but C and D do not give him the highest satisfaction. But the combination A, 600 of mangoes and 150 of fishes, is the highest satisfaction. That is the bundle that gives the highest satisfaction, and it is still affordable by the consumer. So the optimum, the point at which the budget constraint is tangent with the indifference curve, is the choice of the consumer, and it is called the optimum. At the optimum, the slope of the indifference curve equals the slope of the budget constraint. Mathematically, we have two curves that each one is tangent to the other at the point A, so they must be at the point A, they must have the same slopes. The slope of the indifference curve is the MRS, and the slope of the constraint, the budget constraint, is the price of fish over the price of mangoes. I remind you here that both slopes are mathematically negative, but here the author prefers using them in positive terms, so he removes the minus. So consider both slopes as positive, which does not change anything in the calculations, but the calculations remain correct. So the consumer, the MRS, represents the marginal value of fish in terms of mangoes, and the price of fish over the price of M represents the relative price of fish, means the price of fish in terms of mangoes. So the optimum is achieved and determined when the marginal rate of substitution is equal to the relative price. In our example, the optimum is achieved when the marginal value of fish in terms of mangoes is equal to the price of fish in terms of mangoes. So you see here the word marginal. This can be seen as that the consumer optimization is another example of thinking at the margin. You remember this principle we have seen in chapter 1, Principles of Economics, that individuals always think at the margin.